Mm, wait, hold on for a second. Okay, so let's start our class today. But before we start our class, I want to tell you guys that if you guys noticed previously in our here in our missing my screen, right? In this one, in our classroom, I posted a tutorial answer and exercise answer. If you already look at the file, but I was advised that I didn't know before. I just got informed that we in this college we shouldn't give student. I mean, we cannot give answer directly to students. So I took down all my tutorial answer, and there's one more file before exercise. Exercise answer is from our lecture. At the end of our lecture, we have exercise, right? So previously I posted that answer in that file, but I was advised to delete them, so I took them down. So yeah, that's all. I took them down. So for the student that have a problem with your tutorial or your exercise that haven't get the answer, I think if you want the it's not simple answer, suggestion answer, you can ask me, PM me, but there's no way for me or any other lecturer to post our answer or give our answer directly to student because that's not the practice in this college. Okay, so are you guys clear on that? So including our next lecture or next practical or tutorial, I won't give you answer. So you need to capture the answer during our class. So are you guys clear on that part? I think yes. Yeah. So okay. So this week we are in week 6 already. Week 6. So for our lecture today, what we should where's week 6. So for our lecture today, we will cover on the chapter 5, which is refining the requirement models and object interaction. Last week we already finished this one, requirement analysis. Yeah, last week we already covered this part, requirement analysis. So for the last week lecture, I remember I posted this answer in the Google Classroom, but I think only some of you managed to see or manage to capture the answer. But whoever need a suggested answer or solution for this one, you guys can PM me, okay? So this week, let's proceed with chapter 5, refining the requirement models. So before we start, any question or any concern you want to ask? No, no. So I take it as no. So let's start our lecture. Okay. So today we will learn what is refining the requirement model. So before we start, I want to define, maybe some of you are not sure what is refining. Actually, refining is not any specific language or any specific term in OOAD. Refining is actually English, an English word. It's not specific term. So refining is actually like we remove or we cut the unwanted part. So for this chapter, refining the requirement models is we remove the unnecessary or unwanted part in our requirements model. So basically that's what we will learn for today. So in this lecture, this is the course outline. So we should understand what is it mean by a component, what is the definition of a component, and then how generalization and aggregation have to develop reusable components. So generalization and aggregation is not a new term for you guys because we already covered or we already learned this part on, if I'm not mistaken, in our previous chapter, which is in chapter 2, if I'm not mistaken, but I'm pretty sure we already covered this part. And what is reusable components? We will see this part later, but let me brief you guys. Reusable components is actually components that we already developed for previous project, or we develop that components for a new project. That means we reuse other components. I mean, yeah, we reuse that components. Components for OOAD can be your, for example, this is just an example. It can be your use case. It can be your diagram. So that is reusable components. And then next, we will cover on uh, we will learn how to identify generalization and composition. So composition, this is a new term or new thing for you guys, composition. So we will see what is composition and how to identify them and how to model generalization and composition. So we will learn or we will cover how to illustrate or how to diagram generalization and composition. Okay, so basically that's what we will cover for today. It's actually quite, the slide here is not that much. It's around 30. So should be okay or should be short actually. So first, component-based development. This one, if I'm not mistaken, I already touched last week on our last lecture. So component-based development, or what we call as what I call as CBD. So CBD is actually is a set of to reuse enabling the technologies or tools and technique to allow application development organization to go through the entire ID process. But this one later we will see in the next slide. So CBD assembling software from pre-existing components or building components for other to use. Like I said just now, uh, the reusable components is assembling software. That's mean we already have existing, yeah, pre-existing. So that's mean the software or the tools or the components is already there. We use for our previous, it's not our, I mean they use for their previous uh development or design process. So we use them back, or what we call as we call them back, or we build a components for others to use. So it can be the pre-existing or we create a new components, building components for others to use. Okay. So here is the component-based development. So how does this CBD? So we call component-based development as CBD. So how does this CBD relate, or what it is? How do we use the CBD in object orientation? So basically, there are three parts, which is encapsulation, generalization hierarchies, composition, composition, and aggregation structure. So for these two terms, this one already mentioned or already explained what is encapsulation and generalization and hierarchies in our first lecture. This one is something new for you guys. So let's take a look into each of these. Okay, so encapsulation is a process where like we binding. Encapsulation is like we binding or we group the components together. So I think the keyword for you to understand encapsulation, or even me, I take this term as a grouping. Encapsulation is like a grouping, or what we call as binding together the components in one group. So here, encapsulation of internal details which make it easier to use components in system which they were not designed, because they are already, like I said, they are already grouped or binding together. So it is easier for components that are not yet designed. So the next one is generalization and generalization hierarchies. In our first chapter, generalization, we learn this part, or we cover this part as a separate part, because to give you clear overview on what is generalization and what is hierarchy. But now here in chapter 5, they combine this term together already. So let me recap for you. Generalization is actually a process, or no, generalization hierarchies is actually a process to connect your superclass and your subclass. Superclass and subclass. But let me explain. Maybe some of you. Let me explain, or let me recap for you guys what is generalization hierarchies. Hmm. This is just an example. So let's say here, uh, 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 so this is the example of generalization hierarchy, right? The term just now. Yeah, generalization hierarchy. That's mean here in this example that I show here, this is a relationship, or how does the superclass, this is superclass. This is what we call as subclass, can be one or more, but for this example, I use two subclass. Okay, so this is the generalization hierarchy. That's mean a diagram that show what is the relationship between the superclass and subclass here. So your subclass, this is just a recap for this term generalization and hierarchy. This is a recap for you guys. So subclass here inherit the what's the term? Behavior. Yeah, inherit the behavior from the superclass, from the parents. Yeah, sometimes no, we call this superclass or parent, yeah, the parent to the subclass. So the subclass, or yeah, the subclass here inherit the common attribute by these parents. For example, here this purple and pink is a color. So this is a subclass for this superclass. So this is a generalization of hierarchy. Okay. So that's a recap for you guys on this term. So it is make it easier to create new specialized classes when they are needed. Okay, here, specialized classes. Specialized classes is this one. Specialized classes actually this one. The subclasses is the specialized classes of the superclass. That's mean here, color is general, but when you go to this subclass, which is pink and purple, this is the specialized classes. So the subclass can be called, or the subclass, the children, the subclass can be called as generalized, specialized classes. So it is easy for them when they are creating or when they want to create a new specialized classes. And this is a new thing, composition and aggregation structure can be used to encapsulate components. So we will go through this term, composition and aggregation structure, or what are they. But before we go to them, I will explain or I will brief you. Composition or aggregation structure is a relationship. Yeah, it's a relationship between the structure. It's not structure. It's a relationship between the class. Let's say this is a class, pink is a class, purple is a class. So mm, composition actually, let's say, if I delete this class, this super class, is it? No, wait. Composition is, okay, composition is actually a relationship where we delete, for example, I delete this super class, this subclass still can exist, but aggregation, aggregation, if I delete this super class, that means this class can still exist. But we will see later what is this. But that's basically, so one of them is actually when you delete the superclass or when you delete a class, they can exist. But one of them between these two, when you delete the other class need to be deleted too. So it's like they are dependent and independent with each other. So they are two different things, two different relationship. Okay. So here, oh, okay. So here, they don't touch this encapsulation and generalization because we already touched, or they already touched in the first lecture. So they directly go to this one, composition and aggregation. Okay. So composition and aggregation are special type association. So I want to ask if anyone remember what is association. This one I remember last week I asked you guys. So anyone remember what is association? Any of you remember? Jing, Ming, Lim, what is association from our previous class? Or anyone? Okay, I think some of you just open your lecture note, but it's okay. Association is actually a relationship. Yeah, it's a relationship. How does the class connected or how does the class relate to each other? For example, here, this is like, yeah, Jonathan, this is correct. This is a relationship. So let me recap for you guys again. Hello. What was it just now? Hmm. Hmm. This is your association is like Ian said just now. Association is like a relationship. So how does this subclass relate to this superclass, or how does this subclass relate to another subclass on its own class, or how does this pink is connect, or how does this pink is associate with purple? So that's association relationship. It's actually a relationship. One to one, one to many. This is an example of association. Yeah, this is an example of association. One to one, one to many, many to one. This is an example. Relationship between entities. So this is more or less like what Noel explained here. This is an example. Relationship between entity more to one, or yeah, this is type of relationship. yeah, type of relationship. So basically, association is a relationship. Okay, so now do you guys remember already what is association? So for term like this, association, composition, encapsulation, this is a term that you need to familiarize yourself, not only for your study, but in our field. I still remember this part, but this part maybe I don't really remember because we don't really use it in our field, but encapsulation, association, composition can be used sometimes. But what I'm trying to say here, my point here is you need to remember those or some of the term that we use, not only for exam, not only for assignment, but in our field. Okay, if you intend to pursue your career in our field. So this is quite important actually. So composition and aggregation. So composition and aggregation are special type of relationship, which sometimes called as a whole part. Okay, a whole part, that means they are dependent. What we call as dependent here. Dependent, that means they need each other to continue their existence. That means if one is deleted, the other part is deleted too. For example, this one. If I deleted this part, this part will automatically deleted too. This is composition relationship. Okay. So if I deleted this part will deleted too. That means if I deleted superclass, all of the subclass will be deleted too. That is composition. That is composition, okay? Dependent, yeah. Let's use the term here, dependent. They are dependent on each other. They need others to continue their existence, okay? And then the other one is aggregation. Is essentially any whole part relationship. So while superset class destroy, it is subset class still exists. Semantics can be imprecise. So for aggregation, this is just example. Different with composition, aggregation is, let's say we delete this part. This part is still here. This part is still here. Okay? Different with composition. I repeat, if we delete the superclass or we delete any part of it, these two parts can stand alone. Yeah, it can stand alone. That means they are independent. They doesn't need each other. It's not that they doesn't need each other, but they can still continue to exist if one or superclass is destroyed. So for composition and aggregation, what you need to remember or how to remember it easily, you just need to remember that composition is dependent and aggregation is independent. But you need to know what is dependent and independent actually. So that is the general or basic concept of composition and aggregation relationship or association. So before we move, it's not before we move. So until this part, do you guys have any question before we go on to the next slide? Do you guys understand? Okay, cool. So that's pretty much what is composition and aggregation. It's a relationship. So you need to know what type of relationship they are. Okay. Semantic can be imprecise. Semantics is actually, I already look up this term. Semantic actually Semantics is actually in our OOAD, right? Semantics is actually this one I want to explain. Semantics is actually how the UML, how the UML will be used. Why it's said here that semantics can be very imprecise. Imprecise is not what's imprecise, the term not precise. Not precise, not exact, not clear. Yeah, semantics can be not clear because, for example, here, if we already aggregation, right, it is standalone, independent. So for example, If I deleted this part, then this part here, two separate class, is a standalone. So sometimes in our UML, when we deleted this part, we do not know what is the parent or what is the superclass. So by just looking at this, it can be confusing sometimes. It can be not clear sometimes to us. What is this actually? What is this purple? Purple, we know it's color, but for other class that is quite, for specific term that we use to design, when you just look at it, you can get confused. You can get not clear what it is actually. So it can be imprecise for this type of relationship, which is aggregation. Okay. Okay, yeah. So that is semantics can be imprecise because we do not know what's the parent already because it's deleted, but the subclass is still there. Okay. So now we will look into each of these part, which is composition and aggregation. So first we will look to composition. So composition, stronger whole part relationship. The term stronger here, it, never mind, we see this 3 point first. So each part may belong to only one whole at a time. One whole at a time means it is the whole, this thing, this is example. This superclass and subclass is a one whole. That means they come together. They are dependent to each other. So that's the meaning as one whole. So one whole at a time. So when the whole superclass is destroyed, so all its parts, all its subset class is destroyed. Like I said just now, when I deleted this one, color this, the children or the subclass here will be destroyed too. So here for that part, and the individual parts depend on the whole for their existence, such as case is called a composition. So actually let me summarize this whole thing. Actually this whole part actually for this composition is trying to tell us that composition is dependent to each other. So the subclass is dependent to the superclass for its existence. I already explained this now. So I think you guys understand already for superclass and subclass. So that one for composition. So here is an example. So here is the notation. Notation is the symbol that we use. By right, you should know already what is notation. Notation is a symbol. So this is a symbol for composition. Here, it's the for aggregation, but we will see that part later in this lecture. For composition and aggregation, they're using the same notation, but what's different for the notation is for composition, it is filled with black. For aggregation, it is empty triangle. I don't know what this shape. It's not triangle. It's not filled. This notation is not filled. It's black and white. For composition, it is black, and for aggregation, it's white. So here, an invoice item always belong to an invoice. If the whole invoice is to be deleted, if this is deleted, invoice is deleted. So all existent dependent part, which is this invoice item, are deleted. So I want to ask, Jonathan, I want to ask, from this, in this patch, how many UML class you can see? Only on this patch, how many UML class you can see? UML class diagram, how many? Jonathan, are you there? Two, yeah. So there are two UML class diagram. So Kelvin Shark, what is the first class name of the, what is the class name for this one? For this class diagram? What is your class? Invoice, correct. Who else I want to show? Shark. Yeah, Shark. I want to ask, in this UML class diagram, what is the, or what are the attribute in this part? In this diagram, what is the attribute for this invoice class, Shark? This one, this part, what is the attribute for this UML class diagram? Celine, What is the attribute for this UML class diagram? Any of you remember? Noel, what is the attribute? If I explain this time or today, this will be my third time explaining to you guys the structure of the UML class diagram. The first week, last week, and today. No, I'm just asking. Okay, we have an answer here from Farah. Invoice that customer invoice Celine. Invoice Celine. Invoice Celine. So yeah, okay, correct. This is the attribute for this particular class. So your class name is invoice. Your class attribute is this part. Whatever inside this is your class attribute. Okay. So here we have answer from Farah Vincent. This is correct. Invoice number. This is one object in this. So this is correct too. So Noel, this is correct. If invoice item deleted, if invoice item delete the invoice also delete. You ask if invoice item deleted, right? Invoice item deleted, then the invoice also deleted, is it? No, this is the relationship. You need to see where the notation is. So here in this example, if this class is deleted, this will be deleted as well. If this class is, if you take down this part will be gone too. You need to see where is your notation here. Yes. Yeah. You asking me, right? If invoice delete, the invoice delete. But yeah, that's my explanation. You need to see where your notation is. That means if you delete this part will be gone too. That is composition. So am I answering your, okay. Okay, good, Kelvin. Elvin. So here, before just now I asked you what is the structure of UML class diagram. So this is your class, this is your attribute, and this is your process. So this class should calculate grant. So here in this relationship, like I said just now, you need to see the notation here, where it is. So here the notation here in invoice, that means if you deleted this part will be deleted too. Okay. So you guys understand how to read uh this diagram already? But what you need to know, what you need to remember, what you need to know, or what you need to remember the notation, where it connect to, or what is the superclass, or what is the subclass that depend on the superclass. So you need to be you need to be careful when you're reading this, okay? It's not the other way around. This is the superclass here, this is the subclass here. So you need to remember, you need to know where is your notation. So okay. Okay, let's move on, okay? To here, another example here. So this is, like I said, if you see the notation here, notation are the same. This is for composition. This is for aggregation. So like I said, composition is filled with black or black. Yeah, filled with black and filled with black, and the composition, the aggregation is empty. Okay. So this is another example. But let me explain, or let me make it easier for you guys. For example, if we delete class, this student can still exist. Okay, that is for aggregation. That means if you deleted this class can still exist. So let's see, or let's go through the explanation here. So students could be in several class. Okay, this one I already touched also last week. How do we read this kind of relationship? Or what is the association between this class and this student? I want to ask Ivan. Yeah, or how Ivan, how do we read this relationship or what we call as an association? What is the association between this class and this student? How do we read from this to this to this? How do we read? Or anyone? A class has multiple students. A class has multiple students. One or more. Ivan, right? It's okay. So a class has Ivan, here in this example, right? This is the answer actually. Class can have 0 students, student can have 1 too many classes. This is the correct answer by Con Can Shak. Let me recap how to read, but let me copy. This is the exact answer. But let me recap back. How do we read? I copy answer here. Okay, how do we read this association? Okay, here, how do we read is from this class. From this class, we this is the class. We go to here. This is the 0. This is the relationship, and then we go to this part. So here, okay, here class can have 0. So from here you go to go from class you go to 0 and then you go to student. So you read from here to here and then to here. So class can have 0 students. Okay. So from here to here to here. If you want to read from this side to this side, you need to read from here to this one, to this one. Okay, 1, 2, 3, or 1, 2, 3. Yeah. So here we have a two association or relation, two relation. Class can have 0 student. That is the first one. And then we read it the other way around. Student can have here. This one you need to go back to our previous last week chapter. I explained already. So here for this particular association, it's 1 or more actually. 1 to many classes. This one is correct to 1 or more or 1 to many classes. So student can have 1 or more many classes. That's how we read. Student can have 1 or more or 1 to many class. Okay. So do you guys understand on that part? Okay. So yeah, that's how we read. So let's get back to this example. So student could be in several class. Student could be in several class. Several class here is this one. 1 to many or more than 1 class. Okay, more than 1 class. So student can be or student can be in several classes because several classes is 1 to many actually. So several classes. So this student can be in one several classes. So if this class is, let's say I deleted this part or I destroy this part, the student still exists. Okay, so they are independent. So this student do not dependent on this class. That means they are independent. So if the class object is destroyed, the student object may continue to exist. So that is aggregation. Okay, you need to remember this notation. This notation too. So composition, they are dependent. This notation is that means they are dependent, while this aggregation, they are independent. The classes are not dependent on each other for aggregation. Okay? Okay. Any question before we move? No? Okay, I take it as no. So here is composition and aggregation example. I want to ask because I already explained. So I want to ask, this guy, Wong, this Wong. I want to ask, mm, how do we read this diagram? There are two, like this one. There are two association. Sorry, there are two association. So how do we read this one? How do we read this one? Wong, how? How do we read this diagram? What is the association between meal to ingredients? I think it's quite easy. Or anyone can explain what is the association? Content shot. You are the one just now, right? Yeah. So let me copy answer. I think this one I separate. This is what you mean, right? Content shot. You mean two separate relations association, right? Is that what you? Okay, I think you guys should understand. So here from this from the shark just now, I make it clear for you guys. So I separate into two association. The first one, a meal. This is a meal can have many. Like I said, you need to read from meal. I mean from this class to this association to this class. So the class here is meal and ingredients. So the class here is meal and ingredient. So meal can have many ingredients. This is correct. So this is your first association or first relation between the relation between this one and this one. So that one was the first one. So the second was ingredient can only make one meal. This is correct. We just read from this class to this relation to this one. So this is correct. A meal can have many ingredients. That one, the first one. Second is ingredient can only have, I can only make one meal. Okay, so that's why I said it's quite easy actually. So this is correct. A meal can have many ingredients, whereas ingredients can have, this is correct. Oh, this one by Wong just now. Yeah, thank you. So this is correct. This one is correct. Two Feral answers also correct. Yeah, one and only male. One and only male. Because this is but you already state here a male, so it's okay. So that's how you read. So you can ingredient can only make one a male because you said just now a male. So a male it's already one and only. Okay, one and only male. Okay, that's how we read. So before I proceed with the example or with the explanation here, do you guys have any question how to read the association? Any question? Who haven't understand how to read the association? Jeremiah, do you understand? Jeremiah, do you understand how to read already? Okay, then let's move, okay? We move to the explanation. So ingredient is in only one meal at a time. So ingredient is only in a meal at one at in a meal at a time. So this one, the association, this is more or less like the second one. Okay, ingredient is only one meal at a time. So this is the association. I think you guys should okay already, should understand this part already. So if you drop your dinner, this is the meal, the dinner is your meal. So if we drop dinner on the floor, you probably lose the ingredients too. So here what it is trying to say, if we deleted this part, so we will, I mean, if we lose this part, we will lose this part too. Okay? Do you understand that part? It's a composition. Composition as a, like I said, composition as is a group. Okay? Here, this is the example. This is the explanation just now. So here is your example. Okay, composition is a group. So if you delete one, another one will be deleted. So in this particular example, if you drop your meal, you will lose your ingredient too. It's not that you lose your ingredient, but you drop them all. Yeah. So that's the example. So can we move to another complex? Any question? No? Okay, let's move on. So here, this is an example for composition. Here we have three class, which is textbook, chapter, and section. So textbook, chapter, and section. So here, as we can see, they are using composition notation here. This is composition, this is composition. So that's mean this chapter is dependent on textbook. So if this chapter is dependent on textbook, so by right, this section is dependent to the first one too, because they are dependent on each other. So section is depend on chapter, chapter is depend on textbook too. So by logic, if we deleted this textbook, no, I want to ask you guys. I want to ask, what happened to section if I deleted this? Let's say I drop this textbook. What will happen? What will happen to this section, this class, the last class, if I deleted textbook here? In this association, what will happen? Correct. Konkenshak, thank you. If I deleted the first one, the last one is deleted too. Why I say so? Because textbook is, I mean, they are all dependent to each other unless unless this one is unless this one is aggregation. Let's say this is not filled with black, they are using aggregation notation, so this section still can be saved. But for this case, they are all dependent, so once deleted this one, the remaining will be deleted too. So that's how we read. So let's look at the example. Let's look at the example here. So this is probably composition. So why does that probably? Why do you use them probably? But this is a composition actually. Just look at the notation. Okay. So here, any book object is a composition of chapter object. Any chapter is a composition of section object. That's mean they are. This is the two. In one statement, there are 2 points here. The first one is this one. Any book object, this part, this is the first relation, the first association that they're trying to explain. So any book object, so textbook, any book is a composition of this chapter object, and this one is the second one. So any chapter book, any chapter is a composition of section object. So here by this statement, they are telling us that they are dependent on each other. So a chapter object does not have independent life. A chapter object does not have an independent life. Or here what we call it as dependent. They are dependent on each other. Does not have an independent life. It exists only within the object book. So that means chapter can only have if the textbook is there. So this chapter is dependent to textbook. Okay. Do you guys understand already how to read the the composition and aggregation? Yes, section will be deleted, correct. So, so that's how we read. That's how we read composition and aggregation. Okay, you just need to remember the notation and where the notation is. For example, here that means this chapter is dependent on textbook. But if this notation is on this side, so textbook is dependent on this chapter. Okay, you need to remember. You need to know. So that all for composition and aggregation. So before we move or we go from composition and aggregation, before we get into the generalization, any question you guys want to ask? Generalization. Hmm. So anything? Understand? No. Okay. So mm, let's move to generalization. Generalization. Okay. Generalization. Generalization. So this part I think I touched already in the first chapter, but they still want to process with the association here. So this term we use generalization. We use generalization when we want to add class but different in some aspect. When we want to add class but different in some aspect. So I will explain this part later. We'll look at this first. So two classes are similar in most details but different in some aspect. So they can different. It's just an example, but not strict to this one. They can have different to in behavior, data, or association. So this is an example of a generalization. So this is an example. So here is the best type or derived type. But never mind, I'll explain this generalization using this one. Okay, generalization is actually they are from the same class. This is the class. So here is an example. Pink and purple is a color, but they are still different. So pink is a pink, purple is a purple. So they might be different in like here in behavior, data, or association. So that is generalization. So they are from the same class, but they are still different in some of maybe of the attribute, maybe or the data, or maybe the association. Okay, so pink is a color, purple is a color, but they are two different color. Understood, guys? What is generalization actually? Pink is a color, purple is a color, but they are two different colors. So they are different in some way. They are from color, but they are different. They are colors, but they are different. Okay, that is generalization. So purple is a color, pink is a color, and purple is a color too, but they are different. Okay. So here, it can be different in behavior, data, or association. So here, is another example of generalization. So base type, we have a base type as our superclass, and we have derived type 1 and derived type 2 as our subclass. So here, okay, generalization is a, so they highlight is a in a quote here. Is a, how do we read this one is derived type 1 is a base type and derived type 2 is a base type 2. So like my example just now, pink is a color, purple is a color, but they are different. They are from the same class, but they are different. It can be different in data, association, or behavior. Okay, that is generalization. Okay, this is another example. Inheritance is also called generalization because the inheritance is also called generalization because the is a, the term I said just now, pink is a color, purple is a color. So the is a represent a hierarchy between class of object. So hierarchy, like I explained, hierarchy is this one, generalization hierarchy. Hierarchy, that's mean here. in this, I mean the definition of inheritance here, in this hierarchy generalization diagram, inheritance, that's mean this subclass will inherit some of the behavior of the parents or the superclass. So subclass will inherit some of the or the attribute of the superclass of the parent. Child will inherit the parents. Yeah, take it that way. Child will inherit the parents. So for instance, a fruit is a generalization of an apple, orange, mango, and many others. Since apples are fruit, is a fruit, apples may naturally inherit properties. So let me draw this one for you guys. Let me draw this one. Okay, so here, I want to ask, what is our superclass? Rachel. Yeah, you're so silent today. Rachel, what is the superclass from this example, from this statement? What is our superclass? Hello? No, from this statement, this example here. What is the superclass? Yeah, fruit. So here is fruit. Fruit, apple, orange. So I just give two, because I already draw two. So I just use two subclass here. Apa lagi orange? Apple. So actually there are one, two, three, including mango, but let's use two. Oh, here. So fruit is your superclass and or your parent, and orange is our child or subclass. So for instance, a fruit is a generalization. That means this is generalization because they are not specific. So fruit is the generalization of apple and of orange and apple. So fruit is the generalization, and inheritance is actually here. This is inheritance is like a behavior. So maybe apple will inherit some of the fruit behavior. For example, here, apple may naturally inherit all the properties, common properties to all fruit, such as being a fleshy container for the seed of a plant. So this is a behavior, like this is what I call or what I said as a behavior. So apple inherit this behavior of a fruit, common behavior. So apple and orange inherit this common behavior from the parents, from the fruit. So that is inheritance. So again, I repeat, fruit is the generalization of apple and orange, and inheritance is actually the behavior that we or the no inheritance is actually the behavior that it inherit from the parents. So this is the example of behavior. Okay, guys, do you understand that part? Just remember that the superclass is the generalization, and this one is the parent, or the superclass is the generalization, and the subclass we call sometimes as a specified generalization. Okay, but that one I think we will see later. For this part, I think for this example, I think you guys understand already, right? So let's move to the next one. Abstract and concrete class. Do you understand? Child. Child? Child. This one is a child. Subclass is a child. So this is a specified specified class. Yes, specified class. Okay, let's move to abstract and concrete class. Mm, but before we move, can we have a break? 5 minutes. Let's have a break. 5 minutes, okay? Guys, this is just some random question. I'm just curious. Oh, I just want to know because since most of you are around your 20 to 25, I just want to know, is any of you guys already get your vaccine or they just, oh, maybe they give to us first. But you guys already, Daniel, already? But you guys already registered, right? Yeah. First just registered. When did you guys registered actually? I mean, I'm just curious. Last year? Okay then. No, I'm just asking today. You registered today. No, I'm just asking because never mind lah. I just register. So last week resubmit. Oh, this year February. So July. Okay then. Okay, okay. Thank you guys. I'm just curious. Guys, let's proceed with let's proceed with next part, internship. Oh, okay. Sorry. So let's proceed. Okay, let's proceed with our next. So, okay, so you can see my screen back. So abstract and just now before we break, so we learned about, or we covered already about generalization. Generalization. Okay, so now we will move to abstract and concrete class. Abstract. Mm, abstract. I think I mentioned already what is abstract, but we will go through this part later. So a class is declared abstract if it is not it. So a class is declared abstract if it cannot be instantiate, and a class is declared concrete if it can be instantiate. So from these 2 points, I think they are term. They are term. Hold on for a second. So wait, So okay, so abstract from these 2 point, you have a few term here: abstract and concrete, and some instantiate here. Okay, instantiated, or the word instantiation is actually a creation of an object as a member class. That means we want to create an That means we want to create an object as our member in our class. So that's instantiation. So a class is declared abstract if it cannot be instantiated. That means a class is abstract if we cannot create, or we cannot use it as a member of our class. Yeah, a member of our class. So a class is declared concrete if it can be instantiated. So the term you need to know here is instantiation. So instantiation is actually a creation of an object as a member class. Instantiation, creation of an object as a member class. Okay. So abstract and concrete. So this is the definition. Maybe that. So you need to know the definition first of instantiation before we can proceed, or we can understand what is abstract and concrete. So that is abstract and concrete. So known as stereotype in UML, and used to indicate common attribute and method of all subclasses, adaptable and easy to reuse. So first, we will go to before we move to the next page. The first time I explain, or I write here, is instantiation. So it's a creation of an object as a member class. But what is abstract? Mm, abstract actually is abstract is focused as an abstract is actually a focus in the essential feature. That's mean abstract is actually a process where we focus on the essential, no, it's not essential. Yeah, essential features in our class. That means we remove extra or unwanted properties in our class. That is abstract. While concrete is actually a implementation for all of its method. Or concrete is a class that has an implementation. Okay, so abstract is the removal, or we remove the unwanted part, while concrete is the application of Let me think. Concrete. Oh, concrete is a class that has an implementation for all of its method. Implementation of all of its part. Okay. So that's concrete. So it is used to indicate common attribute and method of all subclass. So common attribute, which is abstract, and method of all class subclass is the concrete. So adaptable and easy to reuse. So we will see what is abstract and what is concrete and how to use them. Okay. So here, so here, so in the inheritance hierarchy, this is example of inheritance hierarchy or generalization. Inheritance hierarchy, a class become more specific and concrete with each new subclass, and classes become more general, less specific if you move up the class hierarchy. So let's see. Can I do this? So let's go to the first. Let's go to the first point first. Okay. Oh, so classes become more specific and concrete with each new subclasses. That means if we add more here, if we add if we add more classes here, they become more concrete. That means they become the definition of concrete just now, right? The application of the method. So if we create or we add more subclass here, it become more concrete. And classes become more general or less specific if you move up the uh upper part, up the up the class hierarchy. That's mean, um, like I said, this one just now, like I already explained, this is the generalization and this is the specified class. So if we move this generalization class, this subclass is become less specific. From this example, yes, we know apple and orange is a fruit, but what if no? In OOAD, in our diagram, they won't use this term, the easy term that we can identify. It can be easy sometimes, but most of the time we need the generalization or the superclass to identify or to be more specific what is this subclass is. So basically that's the two explanation here. So the class become more specific if we add more subclass, and the classes here become more general if we move up the class hierarchy. Okay. Actually, the term here is like they just move around the circle. It's still in the same circle, but what's important is we need to know what is the term or what is the meaning of inheritance, what is the meaning of hierarchy, what is the meaning of generalization. It's so hard. What is the meaning of the term? So usually they are in this, it's in the same circle. So class design should ensure that superclass contain common feature of its subclasses. So here superclass, like I said, because like I said just now, the subclass will inherit the behavior of the parents. So the superclass should contain common feature of its subclasses. Common feature, anything that all the subclasses or the child have in common. Okay, so that's the superclass. So sometimes a superclass is so abstract, it's general, so that it cannot have any specific instance. So here superclass is so abstract. That's mean, like I said, this is generalization. So this is general. This is generalization. So this is general. So it is so abstract and it cannot have any specific instance. Any specific instance, that's mean in each of these child or subclass, they have a specific behavior that sometimes it do not, the specific behavior it's not share or do not, it's not common with other class. For example here, mm, For example, here, specific instance or specific behavior of this apple is red, while orange is not red, but apple is still a fruit. So that is the specific behavior of an apple here. Okay, so specific instance. So that's what we call a specific instance just now. So such a class referred to an abstract class. So this class is an abstract class. That means they do not contain or they do not have any specific behavior of the subclass. Okay, understood? But actually, what you need to know is the behavior. For superclass, you cannot have any specific behavior. You can only have common behavior or common attribute that shared by your child, by the subclass here. While your subclass can be specific, can have a specific instance. Okay, understood? Okay. So here is an example of concrete and abstract classes. So concrete is this part, your subclass. So your concrete can have your specific instance. So concrete is your circle and rectangle, because concrete is a geometric object and rectangle is a geometric object. So there are concrete classes. That means there are specified classes, specified instance. Okay. Okay. So this is concrete class 2. Circle and rectangle is a concrete class or specified classes, and abstract is geometric class. Abstract classes. Sorry. I think it's quite easy. This is abstract, this is concrete. Concrete or specified classes. Okay. Do you understand this example here just now? The concrete and abstract class. Any question before we go on from that part before we move? I take it as yes. No question, right? So I take it as yes. So this is an example of an abstract and concrete class. So in the UML class diagram, the name of abstract and classes and abstract method are italicized. So in our UML diagram, that's mean UML diagram, the abstract class in the parent class is italic. So as you can see here, this is italic. Like I explained just now, early of this part, abstract is something that unwanted. It's not unwanted. It's not unwanted. No, it's not unwanted, but it is not the essential feature of our class. So here cannot be implemented, and they are usually italic, right, in italic. So here our class is geometric object. So here our class is geometric object. So this is the property. No, this is the attribute of a class, color, field, that create Java until that. Okay, so this is the attribute. So this is the properties or the function of this class. So the hashtag sign indicate protected modifier. Okay, protected modifier is actually a member. That means the member can only be accessed within its own package. So example here, but this one, I think this is just for your knowledge. The hashtag sign indicate protected modifier. I think in your UML diagram, it won't be many of you using this sign. So it is a protected modifier. That means only the object, yeah, only the member can access the package. So they can only access their own package. Okay, here they get color void. cannot be implemented. Double circle. Okay, so the crucial point of this patch is actually the one to say first, in abstract, we write the abstract class in italic part. So here they said that cannot be implemented because abstract, like explained just now, abstract is external or additional feature. So it cannot be implemented. So if you go to your specified class, which is circle and rectangle, or what we call just now as concrete class, here, as you can see, this is the specific behavior or specific attribute of this particular class. That means circle can inherit the common attribute of the parents, but circle here they specified their own unique what we call as unique behavior of a circle. Then goes to this one. Okay, do you guys understand? Rectangle is a shape or geometric object, but rectangle inherit the common behavior of the parents, but they have their own or their unique behavior. Behavior can be anything. It can be here, can be a process. Yeah, it can be a process here, or it can be it's a process actually. So this is the unique process of this rectangle. You guys understand? Do you understand this part? This look complicated, but actually it's not that complicated. Because maybe here the example in programming language. So it's not programming language. No. This is not some programming language, but yeah, kind of. So do you understand this part? Any question? No? Okay. But since you guys learn programming, right? I just want to ask, this is not in OOAD. I read out this thing. I come across this word. Since you guys learn programming, I want to ask, what is the difference between void and zero in your programming? Anyone understand? Anyone know? What is the difference between void and zero in your programming? Or what is void? What is zero? Void is zero, but what is the difference between void and zero? Correct. Zero is a value. Yeah, correct. So, wow, you guys are pro in programming. So, correct. Zero is a value, void is nothing. It's an empty value. So, in programming, why am I teaching programming? So, in programming, if you want to return nothing, it's return void, not return zero. Okay, so void doesn't return anything. Correct. So, value zero is a value. In maths, zero is nothing, but in programming, zero is a value. So that's just one of my sharing in programming, but it's correct. So here we have example of abstract and concrete class. So two type of staff in Agate. Agate is some random company. So in a company, so there are two type of staff in a company. So they have a creative team and admin team. So this creative team have this attribute, and this admin team have this attribute. So they have their own attribute between the two teams. So let's see. But I think I need to do this. Hold on. Okay. So here, this is from the slide just now. So here, in this company, they have two team or they have two class, which is creative and admin. So this is the specific attribute of each of these class. Okay, here they come out. It's not they come out. They already give you an example here. So this is the common attribute of this because they are all. I mean, these two team are staff in a company. So the class or abstract classes here is the staff member. And then as you can see here, the subclasses or the specific class of this staff is the admin staff and creative staff. You understand? So no, so I mean like from a company, this is one whole company. So in this company, they have a staff. So your abstract class or general class is your staff member. And then they give you these two specific team or this two specific type of staff, which is creative and admin. So this is your concrete class or what we call a specific class. So this is your concrete class. So in this concrete class or in this specific class, each of the each of the subclass can perform or they have their own unique attribute and they have their own unique operation. That's mean, mm, but calculate bonus. But here in this example, they state that these three class has their own, actually here, calculate bonus, it can be eliminated because both has, let me check, calculate bonus. Bonus not both, oh, okay, no, they cannot eliminate because the bonus for creative class is based on the campaign, but the bonus for this class is not based on the campaign. So it is different. So you need to write here calculate bonus because it's different, different attribute or different behavior. Okay, so that's how we write our diagram for abstract class and concrete class. Okay, guys, do you understand? Okay, I take it as yes. So this is another example of a abstract and concrete class. So a person here is an abstract. Ah, here, this is an abstract. And here is your concrete. This one is as example from the previous page just now. So this is your abstract, this is your concrete. So I think by this diagram, you guys should know what is abstract, what is concrete class, right? So here, example, person class declare as abstract class. So person here is an abstract class while the lecturer and student is the concrete class. I think this one is quite easy. So let's move. This is the part where it's not complicated, but this is quite complex. This is the example for this company which they already combined the generalization with composition and aggregation. So since we already cover composition and aggregation, so based on this one diagram, I want to ask you guys, I want to ask. I want to ask Daniel. I asked you already, right? I want to ask Daniel. What is this notation means? What is the this mean? What is it? Okay. What is this notation mean? The fill one and the white one. Daniel. If I'm not mistaken, Tan Sun Yap, right? Let me check first. Yeah, Tan Sun Yap. I remember now, Yunan. So black one is composition. Correct. This one, the black one, is composition, while the white one is aggregation. So I want to ask, correct. Black is composition, white is aggregation. So I want to ask, this one, Wang Zishan. So this one, let's say, if I delete newspaper advert, what will happen to advert copy? Based on this association, if I deleted this class, which is a newspaper advert, what will happen to advert copy here? Gone. Yeah, true. It's gone. So it's deleted actually. So if I deleted this part will be deleted too. Correct. So I want to ask Ferry Vincent, if I deleted this part, what will happen to this part? If I deleted newspaper advert, what is what will happen to advert photograph? Ferry Vincent. Ferry Vincent is gone too. Let me check who else is here. Uh, uh, Jing Ming Lim. What will happen if I deleted this part? What will happen to this class? I mean this class. What will happen to this class if I deleted this one? Remain, correct. So this will remain. Betul, correct, remain. So this is aggregation, this is composition. So if I deleted this part will be gone. If I deleted this part is still there. You just need to see the notation here. Notation for composition and aggregation. Okay. So this is an example of composition, aggregation, and generalization. As you can see here, we have campaign advert, newspaper advert, and television advert. So this is the general part, or what we call as a superclass. So this is the subclass to this superclass, but this is still a superclass to this subclass. But this thing, I mean, this diagram is quite confusing, but because they're using 3 level, but that's how we read. So for these two class, only campaign and advert, this is the super class, this is the subclass. But when we read this advert and this child, this is considered as super class and these two down here as a subclass. That's how we read. So this is the conclusion of the diagram, what we covered already. Okay, I won't touch much on how do we read this part. I assume all of you know already how to read this part. Yeah, I assume all of you know how to read this part already. Okay, so that is the summary. That is the summarize of diagram for what we learned today. So we already covered, or we already learned how to identify and model aggregation. We already know how to identify and we already know how to draw or come out with an aggregation just by using this notation actually. So aggregation and composition and generalization. So these 3 parts we already covered, we already identify and we already know how to read them or how to draw them. And then reusable components and how to model them in a structure diagram. Okay, so basically that's more or less what we already covered today. So like I said, I won't upload any more answer in our classroom. So you need to capture the answer during our class. So this is an exercise. So let's do this now. Okay, so let's do this now. You need to identify, or you need to choose. Okay, This is quite easy actually. The first one I want to ask, Ferry Vincent, are you here? You haven't responded to me. Are you here? Okay. So Ferry, I want to ask you. So I want to ask you. This one, I think your friend already explained just now. This one is composition. You can check on here. The black one is composition and this is correct. This is the answer. So black is composition, the white one or the empty one is segregation. So what do you think is the first relation? Do you think it is composition or it's aggregation for the first question here? Let's say I delete. No, it's not. Let's say. So do you think this is composition or aggregation for the first one? Anyone other than Farrell who wants to try? Yes. What is yes? I mean composition. Yes, the first one should be composition. Why I said so? The first one is composition because you need to have your menu first to have. Let's say this is composition. So this is composition. Should be black all actually, but it's look weird. But yeah, this is composition. This is composition. So that's mean you need to have this in order for you this and this to be exist. Okay. So let's say if I deleted this menu, this all will be gone too. I mean these two class will be gone too. So this is a composition. Okay. Correct. So the first one is composition. So next I want to ask Kelvin Shark. The second one should be what? Crit. Crit, if I'm not mistaken, crit. Crit is something like a rack. It's not a rack. Correct. So, you know, should know already. So second one is aggregation. Why? Because you still have your bit. You still can have your beer bottle if you remove this class. If so, this. Then the third one, Noel, what is the third one? Can you have your meal? Can you have your ingredient if I remove my meal? Noel, what is the third one? Let's say I remove, no. I mean, what should be the relationship? Composition, correct. That one is composition. That's mean if I remove my composition. Let's say let's mean if I remove my meal, my ingredient will be lost too. Okay. So this is the first answer. You should capture this part. So this is the first answer. No, this is the answer for exercise. Okay. No, we have one more question here for exercise one. So this one is quite easy to Celine. Yeah. Celine, what is the answer for this one? This is composition or aggregation? Can you still have your chair if you remove your dinner set, or will this part will be deleted too? So what do you think? Is it a composition or aggregation, Celine? Aggregation. This is Celine, right? Yeah, you should be Celine. So this is aggregation. So you can still have your chair and your table if you remove this part. So they are independent, independent to each other. Okay. Okay. Composition, composition, aggregation, composition. No, this is wrong. Oh, okay, that's the answer. So composition, aggregation, composition, and aggregation. Okay. So that's the answer for exercise 1. Let's move to exercise 2. So examine the two relationship in figure 1. Indicate composition or aggregation by feeling or not feeling. Okay. So then they want to test our understanding on the notation. So they ask us to feel or not to feel. So Nathan, siapa Nathan? Not Ian, the other Nathan. I forgot your name. Yeah, you. Yeah, yes, you. So based on this one, car and windshield, do you think that we should fail or is it composition? Let's say, can we have a windscreen without a car? Windscreen is the front. Windscreen is cermin depan of your car. So can you have a windscreen without a car? So should we feel or not feel this part? No. So do we feel or not feel? So do we feel this part or not? Your answer is correct. We cannot have the windshield. Feel correct. So let's feel. So this is correct. So for the second one, so this is composition. So you need to feel. You need to feel actually this whole thing. So can we have a turtle if we don't have the leg? So this is easy. Jeremiah. I already mentioned your name, but it's okay. Jeremiah, can we have a turtle if we don't have a leg? So do we feel or we don't feel? We don't feel, right? Yes, we don't feel because we can have a turtle even though we don't have a leg. So this is aggregation. This is composition. So we fill this one, we leave it empty for this part, okay? So I think this is quite clear already. So this is a revision for composition and this is a revision for composition and inheritance. So composition is a whole part, okay? Like I said, composition is a whole part. That means if you remove X, Y will be gone too. That is composition. So whole part. The keyword is whole part. And inheritance is inherit from the superclass. So object Y inherit object X. So object Y is a object X. For example, here is color, here is pink. So pink is a color. So that is inheritance. And then composition. This is a composition. This is Earth and galaxy. So we cannot have Earth if we do not have galaxy. So if our galaxy is disappear, by right, our Earth, we all will be disappear too. So that is composition. Okay. Inheritance. Like I said, this is your parents, this is your superclass, this is child, this is your subclass. So child will inherit some of the common behavior by the parents or by the superclass. Subclass will inherit common behavior by the superclass. This is just a revision, okay? So exercise 2, exercise 3. Should you model the relationship between triangle as a composition or inheritance by answer? So you need to identify, is this a composition or inheritance? What do you think? I think this one should be Jonathan Ian. Just turn on your mic. This is a composition or inheritance or both or none of them. What do you think? Because we only have 3 minutes. So anyone want to share the answer or opinion? No. Inheritance. So yes, it is inheritance. Why? Let me explain. Yeah, correct, Noel. Jonathan, Ian, Alvin, and Noel, correct. This is inheritance. Why? Why is it not a composition? Composition, if we deleted this one, the shape, this child will be gone too. But we can have a rectangle and triangle without a shape. So this is standalone. They do not depend on each other. But why it is inheritance? Because they inherit some of the behavior of the parents, some of the behavior from the superclass. So triangle is a shape. So triangle inherits some of the common behavior of the shape. So they are inheritance. Okay, but triangle is still there, is still here. I mean, the triangle is still there even though we already removed the shape. So it is not a composition. Okay, that's the explanation. And then exercise 4. Hmm. This should be the last part. Construct an analysis an invoice. Okay, so we need to construct an analysis class diagram given the following assumption met. So an invoice generate. Oh, okay. Analysis class diagram. Our class diagram should at least 4 entity class with appropriate attribute, collection class, association, no operation. Oh, okay. So they want us to use at least 4. Let's identify first. Construct an analysis class diagram given the following assumption met. So an invoice, this is entity. Sure. Yeah. So this is entity. Invoice is an entity. Customer is an entity too. No, blur already. What I'm looking, highlight. Okay, so this is customer. This is entity too. An invoice might have many order item. So other item is an entity too. The order item may refer to the product. So product is an entity too. Where the customer, we already have customer here. Select a particular product. A payment should be met. So this is another entity. Should be met on the particular invoice. Okay, we already have invoice. Okay, actually, how do we identify if this, what is the entity from our question? Entity is something that have a function or have any relation or have any significant meaning. So here I identified 5 of entity here. So they asked us to give 4 entity. So they asked us to come with a attribute, collection class, and association with appropriate attribute, collection class, association. Oh, okay. Attribute. Attribute collection. Attribute collection class, association, and composition or aggregation, multiplicity, and association. Oh, okay. This question asks us to write or to apply all the things that we already covered. Attribute collection class. So for this part, I think I want you guys to try to do first, and I will give you the suggested answer in our practical class. But this is the entity that I can highlight for you guys. So you need to come out with a diagram that tackle this element: attribute, collection class, association, and composition, aggregation, and multiplicity. Multiplicity is the relationship of the association. Okay, so you need to do, or I will share with you guys the suggested answer in our practical class on tomorrow, Wednesday, on Wednesday. Okay, so before we dismiss, any question? No? So I think that's all for today. We can dismiss. Okay, guys, thank you.